Welcome to this explainer, where we're going to dive into a real medical mystery. We're talking about a disease that hides perfectly in plain sight. We usually think of major health threats as being loud and obvious, right? Conditions that announce themselves with sharp pains, a sudden fever, or just undeniable symptoms. But today, we're investigating a biological antagonist that plays a much longer, much quieter game. This is the story of chronic kidney disease. It's a condition that slowly, systematically dismantles one of your body's most critical filtration systems, and it does it without sounding a single alarm, until it's almost too late. Okay, let's just jump right into this staggering statistic. An estimated 753 million people globally currently have chronic kidney disease. That is roughly 1 in 10 individuals worldwide. To put that into perspective for a second, we are talking about a number that's larger than the entire population of Europe. It's a condition that caused 1.2 million deaths in a single year, making it this massive, sprawling global health crisis. And yet, despite those totally overwhelming numbers, the vast majority of people walking around with this condition are blissfully unaware of the damage happening right inside their own bodies. So, that brings us to the crucial question. How on earth can a global epidemic of this magnitude operate completely undetected by the very people suffering from it? Think about it. If your heart has an issue, you might feel chest pain. If your lungs are compromised, you cough. But your kidneys, they possess this incredible, almost stubborn resilience that actually works against our early awareness. The mystery we're unpacking today is exactly how this biological invisibility cloak functions. All right, here's our roadmap for today's explainer. First, a silent global epidemic. Second, why kidneys suffer in silence. Third, the usual suspects, meaning the causes. Fourth, catching the culprit through diagnosis. And finally, the defense plan, or how we manage it. Let's start with Section 2, why kidneys suffer in silence. We're going to look at the anatomy of a truly stealthy antagonist. The whole foundation of this mystery lies right here, with the nephron. Inside each of your 2 kidneys, there are about 1 million of these tiny, dedicated blood-filtering units. To put their daily grind into perspective, they filter about half a cup of blood every single minute. They're the ultimate workforce. They constantly regulate the volume and composition of your blood, clear out metabolic wastes, and balance your body's acid and base levels. They're tiny, absolutely, but they're mighty. And unfortunately, they are the precise target of chronic kidney disease. Now, here is where the step-by-step biological cover-up happens, and it's actually kind of wild. When chronic kidney disease starts, some of these nephrons get damaged and die off. But your kidneys have this massive built-in redundancy. As some nephrons are destroyed, the healthy ones literally just pick up the slack. They work overtime to compensate. Because the remaining ones are filtering so aggressively, your overall kidney function appears completely fine on the surface. Your body adapts so well to this mild dysfunction that the internal crisis is completely masked. So symptoms stay totally hidden until there's a severe, irreversible decline in working nephrons. Furthermore, and this is key, unlike your stomach or your skin, your kidneys simply lack the abundance of pain-sensing nerve endings needed to alert you when this chronic cellular damage is happening. When we think of kidney pain, we usually think of kidney stones, right? But a stone causes extreme pain because it creates a sudden, acute physical blockage that spikes internal pressure. Chronic kidney disease doesn't do that. It develops slowly and gradually, without creating that sudden pressure. So as those nephrons die off, toxic waste products just slowly begin to accumulate in your blood, totally and completely silently. Moving on to the next section, the usual suspects. Let's trace the origins of this damage. Since the kidneys themselves won't complain, we have to ask, what's actually attacking them in the first place? The primary culprits driving the greatest number of deaths and global kidney damage are high blood pressure, diabetes, and a group of diseases called glomerulonephritis. High blood pressure acts like this relentless physical pounding on the delicate blood vessels inside the nephrons, eventually scarring them. Diabetes, with that high blood sugar, essentially glazes and damages the tiny filters over time. Together, high blood pressure and diabetes drive the vast majority of all chronic kidney disease cases worldwide. If you have either of these, your kidneys are literally on the front lines of a battle you cannot feel. But there are also these fascinating, tragic medical mysteries out there. Take Mesoamerican nephropathy, for example. It's this unusual, rapidly progressive form of chronic kidney disease that has nothing to do with diabetes or high blood pressure. Instead, it heavily impacts male agricultural workers, mostly sugarcane laborers in Central America. Researchers trace this localized epidemic back to severe, repeated heat stress from working long, grueling hours in extreme temperatures. It's a tragic illustration of how environmental factors and intense physical strain can directly destroy kidney tissue over time. Let's look at diagnosis next, catching the culprit and unmasking this silent threat. Because our bodies won't warn us early on, we basically have to play medical detective. And we've got two incredibly powerful investigative tools for this. First is a blood test called eGFR, which estimates your total kidney filtration efficiency by measuring a waste product called creatinine. As nephrons die off, creatinine goes up, and your eGFR goes down. The second is the UACR, a urine test checking for a protein called albumin. See, albumin is supposed to stay in your blood, but if your nephrons are damaged, they start leaking it into your urine. The UACR is a huge deal because it spots this active, early structural damage long before your overall filtration rate even drops. So the whole point here is tracking that eGFR number to map exactly which of the 5 stages of chronic kidney disease someone is in. Stage 1 is super deceptive. Your filtration rate is 90 or higher, which looks normal, but tests like the UACR show there's already structural damage. As the nephrons slowly lose their battle to compensate, the GFR drops through the stages. By the time a patient hits stage 4, they're looking at a severe reduction in function. And stage 5? That's an eGFR of less than 15. That is established kidney failure, meaning life-supporting dialysis or a transplant is required just to survive. It is only during those final stages, stages 4 and 5, that the disease finally, brutally breaks its silence. And the symptoms are devastating. Because the kidneys can't clear fluid anymore, patients get severe leg swelling and fluid overload in their lungs. Because they can't clear waste, urea builds up to such toxic levels in the blood that it can actually be excreted right through your sweat. It crystallizes on the skin in a condition called uremic frost, causing intense, unbearable itching. The kidneys also stop making the hormone for red blood cell production, leading to severe anemia and crushing fatigue. By the time you feel this, the damage is vast and it's irreversible. Which brings us to our final section, the defense plan. These are the countermeasures to protect the kidneys. On the medical front, aggressive blood pressure and blood sugar control are our absolute strongest first-line defenses. Doctors use highly specific medications like ACE inhibitors or ARBs, and it's not just to lower overall blood pressure. These drugs uniquely relieve the pressure directly inside the nephrons, which slows the decline. Recently, SGLT2 inhibitors, which started as diabetes drugs, have been proven to dramatically slow kidney disease progression, even for folks without diabetes. Add in statins for cholesterol, alongside treatments for anemia and bone density, and you've got a robust pharmacological shield to preserve whatever kidney function is left. But listen, medication alone isn't enough. Your daily lifestyle is a massive piece of this puzzle. Adopting a plant-dominant diet seriously improves clinical biomarkers because plant-based foods just produce less acid for your kidneys to clear out. Dropping your sodium intake is non-negotiable for controlling blood pressure and fluid. And this is a big one, avoiding excessive animal protein. Digesting huge amounts of protein forces your surviving nephrons to work so much harder to filter the waste. By keeping protein moderate, you literally ease the physical workload on your remaining filters. Furthermore, managing your weight and ditching high-calorie, sugary drinks removes severe metabolic stress. It effectively cuts off the disease's fuel supply. Carrying excess visceral weight puts massive hemodynamic pressure on the kidneys. In fact, studies show that drinking high-calorie, high-fructose beverages can make you up to 60% more likely to develop chronic kidney disease. 60%! By losing excess weight and cutting out those ultra-processed, sugary drinks, you drastically turn down the internal inflammation and metabolic chaos destroying your nephrons. So that leaves us with one incredibly urgent thought to take away from this explainer today. Chronic kidney disease is an absolute masterpiece of biological deception. It uses your body's own amazing resilience against you to mask its destructive path. Because your internal warning system is completely silent, you cannot wait until you feel sick. You have to take the initiative. So the question is, when will you step up, talk to your doctor, and get your eGFR and urine albumin tested? Don't wait for the silence to break. Protect those nephrons today. Thanks for joining me on this deep dive.